All right. Hello, everyone. Good morning, afternoon, evening, whatever it might be where you are. My name is Matt, and I'm excited to have you all here today. We're going to be talking a little bit about and actually building some stuff with our MCP server at Wherobots. Now, this is something we've been working on for a long time and building quite a bit. There's a lot of new pieces we've added in to our MCP and different product offerings to really make everything we're doing AI native and scalable from there. So that's what we're going to do. We're going to be building with our MCP. I'm going to give people a few more minutes to jump in, but today isn't going to be kind of your standard webinar where we're going to bore you with a bunch of slides and then show you a demo at the end. We're going to go through some of the different things we're building, show you exactly how it works, and then show you what you can end up with at the end of this. So that's going to be our goal today. Now, I will have a few things as we get started here. Number one is in the chat. If you have anything that you want to say, you can drop that in there. I always like to ask people where they're joining from today. So if you want to open up the chat, drop that there. I'll keep an eye on that. When I'm glancing over here, that's when I'm looking at my second screen. So just let me know who you are, where you're from, and then we'll kind of start from there. If you have any questions, you can use the chat, but if you can use the Q&A, it's easier. I can kind of keep them, track them, so I make sure I get to all of those. So that'd be great as well. So if you can check that. And yeah, Rodrigo, we're recording, so we'll have this for you afterwards as well. So we'll have everything there. So yeah, let me know where you're joining in from today. It looks like you got a lot of people joining in, which is great. And yeah, we can go ahead and kind of kick some things off here to kind of show you what we'll be up to, what we'll be building, and everything like that, because that's really the key of what we're going to be building today. Now, here's what we're going to do. Is basically this is what we'll end up with. We're going to build a pretty nothing too crazy, but we'll end up with an application that looks like this. This is a property risk scoring for climate risk dashboard that we're going to build and build everything from from our Wherobots MCP here. So it's all going to be in our VS Code browser. Show you a little bit about that, how that works, and then run through some different prompts and kind of help you understand what's happening there. So it looks like everyone's joining in from Atlanta, Brazil, Gulf Coast, two Brazils. Okay, welcome everyone from Brazil. And yeah, so this is what we're going to end up with. Now, how we're doing that is with our MCP server. So if you're not too familiar with MCP, it basically gives an AI assisted agent. So you have Reston, Virginia, LA, Columbia. Okay, awesome. Welcome everybody. So MCP gives you an AI assistant, like enables you to answer and connect to Wherobots as a data platform. So that's effectively what it does. There's a few different pieces. It allows you to understand both some of the different coding tools that we build and best practices, has full access to our documentation, but most importantly, it can query your data catalog. Now, one of the biggest problems with MCP, if you've ever done stuff like this before, is having well-structured and well-vetted data. That's really one of the challenges to start. It's making sure you have all that available is key. Now, I've actually connected that MCP into Claude as a desktop, if you can see that here. And basically, this is the data that we have that's sitting inside of our organization. And most of this data is available as open data. If you want to connect to that, you can use all this. This is, for example, all the stuff in Overture. You can see kind of what exists there. And then if you join at the Pro tier, you can see all the different pieces here. There's different Earth observation, climate data sets, some supplementary data, and then we're actually adding a lot to this as well because we think if there's more data, there's more things you can do. And we'll be using some different data here, which is actually a sample of the Regrid parcels. So you can actually do some different things like that. So this little image was actually generated from the MCP. When I asked it what data is available, it returned all this information back so it could kind of understand what I'm working with, and then it can build from there. So this is what we're building. Now, if you want to get started, it's fairly easy to actually get started. You can do this with VS Code, or you can just go into the marketplace here and then you can go ahead and grab this. This is our Spatial AI coding assistant. So you can install this in VS Code, and then you're getting up and running. So there's a bunch of things it does. Number one is you can do notebook engineering and build notebooks. You can do the SQL MCP powered SQL execution, which we'll see in a minute. You can actually submit jobs directly to Wherobots directly from VS Code, and you can build notebooks and run them with runtimes that exist in the cloud. So previously, if you ever worked with Wherobots, you had to open up our cloud console on the browser, start notebooks there. You don't have to do that anymore. You can do that all with this extension. So if you're willing, if you want to get started, I'll drop that in the chat. You can go ahead and grab that, and that will get you started with our VS Code. There's a few questions I wanted to ask with the polls, so I'm going to drop a quick poll here. Just trying to see, kind of what problem you're trying to solve with these agents, and what you hope that they'll do. So if you're here and you're trying to do something specific, if you can go ahead and answer that, that'd be great. And you can kind of answer that in like a free-form response for what you're trying to solve with some of the AI agents. So let that run for a second. You can drop some answers in that really help us kind of understand what you're trying to do, and we can go from there. So that's how we set it up. It's really that easy. What that looks like in VS Code, when you open that up, is once you've installed it, you'll see that here. And you can see you just have to put in some settings. It'll ask you for some different settings here for these different pieces. And all you really have to do is set your API key. So if you go Wherobots, set API key, you input that there, and you can have all of your different pieces here in VS Code. So you just set your API key, and then you're up and running. And that's really all that it is. Now, with the way we do this, we connect that through the VS Code coding agent. There's some free agents. You can also set that up for Copilot. There's a number of different ways to connect that if you want to use Cloud Code or whatever you kind of want there. There's some different pieces. So now that we're up and running, as you can see here, if I have a workspace running, you don't need a workspace. I'm going to use that later for a notebook that I'm going to build with the MCP, and we'll go from there. So I see some different answers here. Let's go ahead and end the poll. Can kind of view some of the information, I think. And yeah, so thank you for the poll. I can kind of share some results back, I think. So it should be there. Thank you for doing that. I'll have a few more questions as we come through the poll here. So a few more questions as you have going further. So let's go ahead and get started. What I'm first going to ask, and I built this whole process over here, but I'll kind of walk you through what the plan is, and then we'll actually go and run some different queries against the MCP and see what we get back. So the first is just data exploration. What wildfire data is available in the Wherobots catalog? Show me the 20 largest wildfires in California in the last 5 years. What parcel data do we have? So this is really just understanding the state of the data we have. It helps give some memory into into the chat, so it kind of understands what we're trying to do and accomplish. So that's helpful there. And then we start to ask some very specific questions, like find all the residential parcels in these zip codes that are within 3 miles of wildfire and burned more than 1,000 acres since 2020. Of those parcels, which ones are in a FEMA flood zone, A or AE? Add a column showing which these structures have been built before 1985. And we can collect all this from the data that we have. And then we can create this compound risk score that is basically distance to wildfire, FEMA flood zone severity, building age, and roof material. And we can kind of rank them or weight them using these metrics. Now, these are, things you could do with code or SQL or anytime you want like that. So you could certainly do that at any time, but this is what we do here. So right now I'm going to use Claude Sonnet 4.6 is what I'll use. And we'll go ahead and ask this question. So what's going to take place is it's going to ask its different questions here, and then it will connect into the MCP, and we'll start to see what it's asking in the back end here. So you can see it ran the MCP server request here. It's looking through our data sets and our catalogs to see what's there and exploring for the different data that it can use. So it's going to keep looking through that, through some of the different databases. It's going to scan everything you brought in, right? So you have some different here. You can see there's flood risk, severe weather data inventory. It's concurrently querying these things and understanding what's there. And it's kind of finding all this different data. So it's looking for more information. And yep, there's a wildfire data set in the pro weather data, and it's going to get its schema now. So it's going to go ahead and figure out the schema of the data. So you can see it here. Here's all the different data that comes along with it. So there's all this stuff. It's kind of doing this exploratory data exploration as it goes along. So here's the data, tells us the information about it. These are the two spatially enabled weather data sets that you use for proximity and so on and so forth. Now we can go ahead and ask our second question. So let's go ahead and ask, show me the 20 largest wildfires in California in the last 5 years. So this was first just data exploration. What we can do now is go ahead and get some more things that we just kind of want to study this. So it'll do that. It will look for the state filter, and it's going to load the execute query tool. This is actually going to build a SQL query that it queries against our database here. So it's going to connect to the database, and then we can actually take a look at the query that it's going to run. So it's going to spin up that runtime. It'll go ahead and connect to that. Once that's been established, then you can see here's the query that we're running, and we'll get that back. And we should see the result here that gives us the top 20 wildfires. Now, what's cool about this is a few things. Number one is I can do my data exploration to see what's available. And that's always good to kind of prime it to help it understand what's there, things like that. And then we can also start to do some of this very basic data exploration. So it's going to run this query, and then we'll get that back. Again, this is all connected into our documentation. So anything that you might need or want to run an advanced query or stuff like that, you can also give it some direction here as well. If you wanted to do maybe a KNN query to find the, 3 nearest fires to every parcel, you could do that as well and get the average distance to the 3 nearest fires. So that's something that you could do on top of that. But again, that's all in the documentation. So you can always kind of prime the chat with that extra information and go from there. So I'm going to launch the second webinar question here and see if we can do that. I'm just curious to see what platforms you're using to solve these problems right now. If you're using things like VS Code, Claude, OpenCode, Cursor, something else. And if there's something else, let us know in the chat. We'd love to hear that. So just kind of curious to see what platforms you're using to do some of this kind of agentic programming today. So R and Gemini. Okay, cool. Looks like a pretty pretty even split between VS Code and Claude Code. Okay. And while that's running, I can actually take a look at what we got back from my full chat, which I was running before. So what you can see here is that you can take a look at the data set here. It's going to return these are the largest fires during this period and actually establish that, the data was only up to 2015. So it's going to pull these are the 20 largest fires between 1999 and 2015. So it's going to do some different things there. So you can see all this. Here's the acres burned. Here's the cause, all the different information that comes along with that. Okay, so it looks like majority of people are using VS Code, some Claude Code as well. VS Code and Cursor, Vim and Claude, and then some Postgres as well. Okay, very cool. All right, thank you, everyone. So I think I can just share the results there. So if you can see that, those are the results that we got back from the poll. Thank you for going along. So you can see here, let me check here as my query is going over here. It's, you can see they're all Class G fires. Lightning is the dominant cause. Some are in the county and they appear as FIPS codes, stuff like that. So I can kind of keep going as that one's running here. And then I can start to ask some questions about what parcel data do we have for California. It's going to review everything that's there. It found the Regrid parcels just from a data partner of ours. So it's found some different information there. And as you can see here, it has all this different information about it. It actually contains the FEMA flood zone, which is exactly what we want. It actually had access to kind of my prompt plan. So it actually can read that and get a little bit ahead of itself to say, here's what it wants to do, which is really good. It's also the open footprints. And it can see here I have height, roof material, roof shape, roof color, which again was some of the different information that we wanted. Now, another key thing to think about with this is, kind of helping create the plan as you're going along. Looking at the data you have, you can do that kind of on your own. You could also use the AI assistant to kind of help create a plan and structure as you explore the data and go from there. But again, if you have some of this data yourself and it's your organizational data, or you brought it along, if it's well structured and pulled in as the system, the more data you have, the more it can kind of start to create this plan and pull from different data sources. So maybe you have a data set of buildings that's roofs that have complete roof data information. Some of that data is missing with the Overture data set. So some of those things you have, some of those things you don't. But for the most part, you can kind of find some of those pieces here. And if you have your own organizational data, we'll read that in as well. So this is reading not just from our open data sets, but from any data set that you bring into the platform. We'll show you kind of how to bring in other data. You can create jobs and runs and things like that with some of this different data as well, which is really good. So here's what it's doing here. So now I'm going to ask it to find all the residential zip codes that are within 3 miles of a fire that burned more than 1,000 acres since 2020. So it's going to look for those. It found the 3 miles. It's going to use STD within. It's going to run this query here. Here's the output that it's run. And you can see all the different pieces it's pulled together here, which is great. So it's going to check this. It would need to recorrect its query. Fires exist nearby. The geometries look good. All these different pieces, and then it's pulling in the different zip codes with the major fires here that have existed. So those are some of the different things. So it pulls that in, it runs this, pulls the different property parcels here, and you can see it's giving this for, LA County. Here's the distance, year built, FEMA flood zone. This is all sort of results from the queries that we get back, and then we get the data set here, and it can restructure this response for us. So you can do all these different pieces here and go with some different pieces. So it actually, again, jumped ahead. It does the filtering for the flood zone and building the compound risk score, which is what we wanted. I see if things, yeah. So this finished up over here, so you can see this. It came to the same result that it had data from 2015 forward. So considering some of these queries take successive time, you can kind of see how that's working. But we can go back and kind of continue to restructure this as we go forward. So what we found here, we found these residential parcels in a FEMA flood zone near a wildfire. These are the property structures that we found and the ones that were built before 1985. So it's going through and finding all of these different property parcels that we care about. Again, there's more data that we could process here, and at the end of the day, you could scale this up to as nearly as high of a volume that you want. The most important part here is that this is, we have a sample of data from the property parcels, and then there's a mixed bag of data from data that has data from the roofs or that is like roof material and stuff like that. Some of them are like unlabeled parcels. There's different things here, but again, that as the data and quality improves, you can get some different pieces there. So what it's going to do now is the most complicated part, which is create this compound risk score from 0 to 100 for each parcel. So distance to nearest wildfire, closer equals higher risk, FEMA flood zone severity, building age, and roof material. And here's the weighting. So the wildfire is the highest one, 40%, flood at 30%, age at 20, and roof at 10%. So here's the query. It's going to check which the materials that exist for the zip codes, so can design the scores properly. And you can see here that it has some different qualities. A lot of them are null. Some of them have tiles, tar paper, stuff like that. So there's a lot that are like, there's only 46 records out of 1.2 million. So it'll have a sensible default for nulls. So it automatically spotted that and recorrected that. And then it ran this very complex query here, as you can see, to build this out. And then it also did some optimization to do a spatial join by removing the unnecessary joins. So you can see here it saw an issue. It removed some of these different data sets. It pulled the 50 that it cared about with the roof quality and stuff like that. And then was able to create all of these compound parcels here for our target zip codes, which we cared about. Again, we're limiting this quite a bit here with some different things. So I'm going to run one more poll here while we go through this. So how was your experience with the agent? Understanding like from the agents that you've used, what worked, what didn't, what was painful. Anything you can kind of give us as a clue in terms of what's working or not with some of the coding agents you're using would be really great to kind of understand how we can improve ours and help you kind of going forward. So with that said, here's the scoring model summary. And then what we do now is we actually are just running kind of concurrent queries against our existing data. But we need some process to take that and turn it into a real data set that we can use. There's a few different ways you can do this. I'll show you two that we built here. The first was actually generating a notebook. So I had it build a complete notebook for me that you can see here. And this is running on a Wherobots runtime that's remote. So what I'm doing is I can basically start my runtime. You can see here I have it all set up. I can stop it and do some different things with that. But at any time I can start one here. You can give it a name, give it the sizing, and that will go ahead and start your runtime there. Once that's all set up, and again, this notebook was generated with the MCP agent, it's going to basically allow me to connect this and run my very, long, kind of complicated query here to build out my scoring system. So that's what it's building here. And then what it'll do is print the result. So what I can do here is, I need to, I guess, restart the kernel here. And let me make sure that that's running. Session's been disposed. There we go. Okay, so it's connected. And now this is connected to Wherobots Cloud. So it's running with our cloud server. It has everything there. And that's all collecting connected to the cloud server here in the infrastructure. So what I can do is now create this compound score once I've connected my local notebook to the remote runtime. And let's check the results here. So I'll end the poll. Thank you for those who answered. I'll just kind of share some of those results here so you can see those quickly. Can't see all the results on my end for the open-ended questions, but that looks, I will check those afterwards. So thank you for those who participated. And now I'm connected here so I can actually run this complete query. So what this does is it takes all my scoring, and it's a lot of complex SQL, which is, you know, it does a lot of logic and embeds a lot of those different things into this, which is really great. So I have all my property parcels. I'm filtering out what I need here. This is on the validated data that we have in, but this could be data you bring in or anything like that. I create my fires query here to get the fires that I care about between these different bounding boxes, join the parcels here, find the distance using distance sphere. So it's doing not only some advanced SQL, it's doing some distance weighting here for the, the order of distance, finds the nearest one, does some scoring here as well. So here's where, that does the actual scoring logic. Here's the FEMA flood zones where it takes that and actually weights it based on the scoring for the different FEMA flood zones, the age of the building, which is here. And then it does that weighting for the complete score down here from our compound risk score. So I can go ahead and run that. Excuse me. Let's see here. And did I get a... Should be. Let's see if that worked. Of course, as a live demo, it doesn't want to go through, but let's just see what happened here. See if I can correct that. I know what's going on. Stona. Sedona.sql. Okay. So that's going to run our complete risk score, and that ran here. So it's pretty fast. It makes it super efficient and scalable from there. Now, what I did at the end of this was I pushed this out as a GeoJSON file so I can build our web application. That actually pushes directly into the cloud. So once you have that, it's going to be something that you can go ahead and download from your Wherobots Cloud console. So if I go over here, all I have to do is go to cloud.wherobots.com, go into my storage here, and you can see here I have my scores final, and here's my final GeoJSON file. Now, another thing that I did is actually turn this into a Python job. So let's say if this data is updating on a regular basis, or you're updating these base files and you want to run this on a weekly basis or a daily basis, now I have a job that I can run that's a part of our pro tier, which you can get access to. And this will run on whatever sort of frequency you want. So you can keep updating these scores all the time, and they're already connected to those data sets, and you can schedule that. There's a few different methods for scheduling that. You can run that just as a job here with the Wherobots VS Code extension. So you can submit a job and do that as you see fit. You could orchestrate that locally to kind of run every, so often as you wanted. If you want to get more advanced, you can do that with Airflow as well. So there's all these different options to basically take the notebook, build it into a job, and keep that running on a regular basis. Because, for the notebook, it can, it's something that you can run on a periodic basis. But with a job, you can do some different pieces there. So question here. Sounds like you work with a lot of state water agencies, given the complexity of the SQL queries underneath. How do you ensure accuracy? Do you recommend doing multiple runs and see if you end up with the same result, or you phase the queries with another LLM manually and then do the runs? So what I do is, this is sort of like the first layer of exploration is kind of what I want to show. And I'm doing a series of these. So we'll be doing one every week, basically, on different use cases. What I like to do is a few different things. You could do some more advanced logic and build that in with your coding agent. So if you had some specific skills that you wanted to encode to say, here's some of the pieces, and I don't know some of the specific things that you need to do. Here's some of the checks that you need to do against the data. Make sure if there's missing elements, clean those up. Here's the logic we need for scoring, and here's how you can do that. If you do multiple runs, again, it's ensuring that the base data is consistent and clear. Like this is, the data here, we have some data from open data, which obviously you see there's like some of it has roof data, some of it doesn't. That's one thing. If you have that data already and you know it's accurate, you can do that. And if you need to kind of like update, adjust, or rephrase the queries, you can do that. And I would actually do that through the agent process and using the context that you're building here with the chat. So the more information it adds in progressively, both from the catalog or from our documentation or things like that, it can progressively build that and make that better and faster. Again, it's not going to like be the brain behind this. You have to bring that forward, but it's going to assemble it much faster. I did this in about maybe an hour, hour and a half, all said and done. So you can build something very, very quickly. And this is, sort of like prototype phase, but you can get more in a clear production phase and scale from there. So I think that's a good point to call out. You can prime the agent with more context, but you also can review and look at these things and make adjustments. What I like about the agent, some of the VS Code integrated agents, like let's say I see something that I don't like here, I can select this code and prime it to say, hey, fix this or adjust this or look at the documentation and go from there. Because I've taken this context from lines 93 to 106. I can put that in and say, can you validate that this is the best way to run a KNN query and go from there? And there's some, that's one optimization I could see right now that we could potentially do. So there's a few different things like that, and you can kind of build that, but it builds this advanced logic very quickly. And now I have this working score. So I've gotten that. I've downloaded my GeoJSON, and then I've asked it to finally build an application here. So I'm going to have it go all the way down here. There's some other things here that I was cleaning up, and then it built me this single page application. So what I did is primed it there. I told it to build it with MapLibre, MapLibre GLJS, color each property score using this scoring metric, add a sidebar that shows the total property count, and then click that here just to build a very simple dashboard. So it did, it built the index code here. This is our complete JavaScript application. Nothing too advanced or crazy, but then I can pull those pieces in and review them there. So let's go to the application so you can actually see all the data work that we built into it. And if I'm just going to refresh it here, as you can see here, it pulled into our zip codes. We have our different zip codes here. I think one borders each other, or sorry, two zip codes here. And we pull those in and we can take a look at what we have here. So if I click on any property, you can see here that this specific property has a low risk score. These are the scores for wildfire. It's 35 years old. Here's the assessed value. The nearest fire was 15 miles away. Here's the flood score, and here's the roofing score. So you can see some of the different scoring here that it's pulled together. Now, what I can do is also do some very basic filtering. So we can see that the areas that are most at risk are actually all down here. Looks like these are some different properties. You can take a look at what they are. And it looks to be in this very specific area where it has a combination of these high flood scores next to this park here. The wildfire score isn't that high, but these are very old buildings and the roof scores are old. So if we expand that out a little bit, it still seems to be tied a lot to this area here and going from there. And you can click to see these different things here. So I see a few more questions popping in. How do you handle validation when your ground truth data has spatial uncertainties? How do you implement testing? So if you have some sort of ground truthing or validation, if you have either data that you can check that against or validate, that's a good way to start to handle that, or have some kind of scores that exist. That's one piece. If you have some sort of field data collection as well, you could also bring that in and validate that from that perspective. So generally, I think what also helps is some like kind of comparable framework. Right now, I'm having it build the scoring mechanism for me because we're just doing a kind of a demo today. But if you know the scoring mechanism that you want to create and all those different pieces, those are some things that you can kind of have and scale from there. What are the risk protections if a non-experts get a false sense of confidence in their work? That's a good question. I mean, I think a lot of that is, again, how you can build in some of the logical guardrails with some of these pieces. I think that if a lot of what we're doing right now is really built for, adding some sort of like spatial acceleration of the development workflows that you're building, right? Having the AI kind of assemble the SQL for you, understand the data that's underneath it, you can actually get deeper. Removing that work, I think, actually allows you to build in more of your expertise into the coding agent and stuff like that. So using what you want to build, whether that's validated ground truth, whether there's other pieces there that you can actually bring in and have the SQL run against that and validate and check and adjust, you can go to there. And you can also put logical guardrails on, sort of the MCPs and the different pieces there to say, here's what we do want you to have access to. Here's where you can build different applications and stuff like that. Um, I think the more we see this is that, this is helping you accelerate the spatial processes that take large amounts of time to actually get to the logic that you want to build into this in the first place, right? So the fact that we're able to go from idea to prototype to dashboard in an hour, that's the change of what we're trying to do and bring that forward. Maybe not have the AI provide the answers from that capacity. And again, there's different controls here and within your organization as well. If you only give validated output data to the MCP or those specific users, that's all they'll see. So certainly if they ask questions of maybe this final data set here, and you're comfortable with that because that's what you would be putting in your dashboards anyways, then that's an okay thing to do. So those are some of the pieces there that you can add in, and it can control some of the fundamental spatial queries, like find these things around me, tell me the aggregate scores in these zip codes, stuff like that they can do on a very basic level. Those are where you can put the controls in the AI and stuff like that. So yeah, it is important to kind of understand where you're handing off control and how much you're giving to it. But I think this is where you can structure it with sort of a clear skill on how to design the risk score, a validation step, all these different pieces you can build into the logic on the back end. So this is really, I want to kind of explain in how to show we can accelerate this. We let the AI in this case decide the risk framework, stuff like that. Or sorry, decide how to design the queries. But again, I told it how to build the risk scores and stuff like that. And you can validate the SQL and go from there and see all those different pieces. So at the end of the day, here, the majority of the risk scores seem to fall along this area. There are a few more down here as well. But I think interestingly enough that the fire risk wasn't terribly high here based on the data that we had access to. It's actually much more about the flood risk, which seems to be something along this sort of area here where there might be a river or something like that. And then we can actually take this further. You could get, the total property values in this different area. So you could do something like that. You can kind of, scale this up and look at, other kind of risks in the area and these different things. So it gives you kind of this clear view of how to start to build that and scale those different pieces. But again, bringing that forward into how you can do some different pieces and scale this there is the important part. How I recommend using this, and this is just kind of one of a series of demos we're going to do to kind of show you this. What I would recommend doing is, you can sign up for Wherobots here. There's basically, you can sign up here. There's a 30-day free trial that you can get access to. So that allows you to do basically everything we did today and create jobs that allow you to bring in any data that you want. So I've brought in remote data that I found of value on AWS open data. I've pulled in storm warnings, zipped up shape files that live on a remote server that need to be downloaded to pull the process. I can create all those jobs and move more data in. So that's kind of this step here, is to create these jobs of data that you find valuable outside of just the stuff in the catalog. I still recommend using all the stuff in the catalog and understanding what's there, and then start to kind of build some of these, mini prototypes that you are interested in. You can kind of, see how you can kind of scale these up, start to develop some different components around it, and use that to accelerate the SQL logic. I think the three most important things with the MCP is the ability to understand what's in your data catalog. And with the way we have set up our data catalog, which you can see here, everything has strong metadata around it. So even just out of the box with the open data, you can see what we have here. If you go into the different data, here's the different catalogs here. You can see the record counts. It has historical snapshots. So we have strong metadata around what's here already and some of the different definitions. So there's a lot of information there. And then you can do the same for data that you're bringing in. These are all data sets that we've been bringing in and building and stuff like that. With the Wherobots Pro, you have some partner sample data here, but then you can also get access to all these other data sets from, satellite imagery and those different things too. And then I really recommend starting to, build some understand what's available, build some different notebooks to do some testing, and then convert that into a job to produce what you want from there. And then once the data is there, you can kind of connect it into the different pieces you want. If you want to export the data to bring it into a different system, you can do that. If you want to use one of our partner connectors, if you want to import this into a tool like Felt or Descartes or some different places, you can do that as well. We also connect into Databricks. So it kind of allows you to go into all these different places and scale from there. But I think the most important part is that it has strong spatial SQL logic, and you can push it to ask it to optimize the query more, or, look at different ways to do the joins. If you have raster data, we can bring that in, do raster joins as well. So you can kind of construct these more advanced kind of composite scores or different analyses like that and build those to scale from there. So that's kind of the goal from today. I would recommend going out and checking this up. If you want to sign up, you can sign up for the pro tier here and start with the 30-day free trial. That gets you access to the MCP, everything like that. And then it's really convenient now because I can just run all this from my local, VS Code. I can keep my projects organized and stuff like that. All the data lives in the cloud. It comes along with cloud storage, and then you can start to build some different solutions here. So I think there was one final question that we had. If you're potentially interested in doing like a reverse demo, and basically our product team is looking for people to give us some strong feedback on this, help us understand, kind of what we can do. And what we're really looking for your help there is to, do this with stuff that you care about, understand where the agentic features are coming into play, and then actually going along and doing with us together. So we would really love your help to take this for a test drive, help us learn what we can add in, how we can improve, and see how you're using it. Because the more we get it out there to work with folks like yourselves, that's great. That's kind of what I had for today. These are going to be kind of short, direct webinar series that we're doing across different use cases. Stay tuned for more. Take this for a spin, sign up for the pro tier, and give it a spin, and let us know what you think. And for all the people that have signed up and volunteered to kind of go on a test spin with us, we really appreciate it. We'll be reaching out to you to learn more about that. But there's a lot changing in all these kind of AI assisted tools. We're doing a lot of work on integrating into them and helping to create that very easy connective layer to build these different systems. So we're just going to keep showing what we can do here and getting more ideas. And that's kind of what we had for today. So don't need to drag it on, but thank you so much for taking the time to join us. We really appreciate it. We'll be reaching out to you. And then we have another one coming in the next couple of weeks. So stay tuned. If you want to watch us do this on different data sets, we will be doing that going forward. So thank you, everyone. And we will see you in the next one.